probably wash my hands every time I use them, but they're
yeah, no, I just want to hard
Marin is here. Nina. Okay, we've got 1:30. Why don't we get started? Good afternoon, research methods. Happy Halloween. Here, as you can see, for Halloween, we have our normal distribution, and we have our paranormal distribution. This was found on Facebook by one of my former students. She's actually now studying statistics in graduate school, and her grad professor in stats had this up the other day, and she posted it on Facebook. I thought I had to bring it in. What a wonderful way to get started. And what a spooky day we're going to have. We're going to have a spooky day because as it ends, we're going to hand you homework assignment number 3 that's due on Friday, and we know how spooky homework assignments can be. So that's one part of it. And we're also going to manually be computing some ANOVAs today, and that's really spooky also. So it couldn't have worked out for a better day of the year here on Halloween. Okay, so to get us started, why don't we do this? Why don't we go out to our S drive, and we're going to open up a new set of practice problems, ones that we haven't seen before. So if you'll join me by going out to the Matthews N file. And if you get to our Psych 200, section 03, and we'll go into our practice problems, there's now a new folder there that says one-way ANOVA problems. And while people are clicking their way in, can somebody remind us, why do we call these one-way ANOVAs? What does that imply? Okay, one variable, specifically one independent variable. Okay, we have one independent variable. And then we're going to have, in the not too distant future, more than one independent variable, but we have a lot of things to learn just about even the one variable case. If we open that up, we go to the one-way ANOVA opportunity, and then there's an ANOVA basic ratios. Okay, if you can get that far, ANOVA basic ratios. And then there are 2 Excel files. This week, we're dealing with the independent groups design, and we sometimes call that a between design. So click on the one that says between. Next week, we'll be doing similar computations using basic ratios again, but this time around, we'll be doing, the within subject variety. And you might see something that looks something like this. When you get in there, you should see a problem that has 3 groups. So just by a show of hands, how many people were able to get to that? Okay, well, let's see if anybody's having any difficulty. Sometimes our computers have been going down on us, but I think that's just about everybody in the class has got that up and working. Okay. All right, so we'll do now some computation, and we'll also pick up on the handout that we had from the other day. And I have plenty others lying around here if you didn't get one from the other day. Anybody need? Okay, a couple of folks need a between subjects handout. Rachel needs one. Anybody else? And we'll be using both sides of this page. So just to remind you, yesterday we stepped through, actually 2 days ago, we stepped through the concept of ANOVA. I tried to understand when we use it, what's the logic behind it. Then we took a peek at how we might begin partitioning the sums of squares yesterday using these basic ratios. And that was one of our mantras and one of our extra credit opportunities, that the basic ratios help us get the sum of squares. And now we'll see if we can go ahead and actually make the computation. So today's going to be a hands-on day. One of the ideas that I have for a big picture for today is we'll go through these computations in Excel, and then we might see if we can do them also in SPSS. And then because we like to make this rehearsal time, we might do a second problem all the way through like that. We'll start out in Excel, we'll compute it manually, and then we'll see if we can corroborate that number inside of SPSS. Okay, so that's where we're going for today. And if you've got this up, you can see that we have 3 groups. And how many people do we have, or how many scores do we have in total across these 3 groups? Let's yell it out. Across the 3 groups, we have Okay, so we have a total of 12. We have 3 sets of 4, so we have 12 scores here. Now, here I'm using a generic group. We could think about this lots of different ways. The other day we were considering a possible cholesterol experiment, right, where we had 3 different groups. These are not really plausible cholesterol numbers, but we might stay with that idea just to get the ball going here. And then we'll put in our null hypotheses. So can we all yell out our favorite prepositional phrase? I mean, you can key it in with me. Our favorite prepositional phrase is? Wow, okay, you showed up on Halloween. That was a little spooky. In the population, what happens? Anybody know what the null hypothesis is going to state here for any ANOVA? For any ANOVA? Thanks, Katie.
Is it all means are equal?
All means are equal, right? So all means are equal. So that would suggest that mean 1 is equal to 2, 2 is equal to 3, 3 is equal to 1 in this 3-group case. Okay? In the population, all means are equal. Okay? Why don't we copy that down just to save ourselves a little bit of time, and we'll now change that into an alternate hypothesis. A couple of things we have to do. Anybody want to yell out what we have to do here? It's not HO, it's H1. Okay? And then it says in the population, all means are equal. We should change that to... Okay, so I'm going to be careful about that just for a moment. We're going to say not all means are equal. Okay, and we're going to pause for a moment there. We'll let you put that in. In the population, not all means are equal. And I'm going to try to make a subtle point, in this case, not about mathematics, but about English, and how we use our terms relatively carefully here. We would say that in the population, not all means are equal. We are not saying, in the population, all means are not equal. That was a very subtle difference. The distinction is between not all means are equal versus all means are not equal. First, who can at least hear that difference? Okay? How many people think they have an appreciation for how those two things really do mean something differently? Okay, do you want to pick up on that? Can you maybe explain?
When we say all means are not equal, it means every single mean is different from the other.
Yeah.
And when we say not all means are equal, I mean, 2 means could be the same, but it doesn't mean like all.
That's beautifully explained. How many people followed that? Okay, all right. So what we're saying is at least one of these, the alternate hypothesis is calling for at least one of them to be different. And had we said in the population all means are not equal, that would mean that group 1 and 2 have to be different from each other, group 2 and 3 have to be different from each other, and finally group 3 and 1 have to be different from each other. Just in case that isn't entirely clear, I do have something out on the S drive. You don't have to go there now. I'll just pop it open. I have these writing tips. Because when you start writing up psychology reports, sometimes you'll make mistakes like that. We call these ambiguous negations. And let's see if I can find that one here. I might not have it. I'm sorry, I've loaded the wrong one. Anyway, I will put up on this PowerPoint sometime later today, and it will be available to you on the S drive, how to think through that distinction, the one that Meg just gave to us. So she gave it to us correctly, right? We were talking about having at least one mean not being the same as the others, and that's really what we're looking for here. Okay, how many people have that in as their alternate hypothesis? Is that working? Okay, really good. Let's go over then and start putting in our computations for these basic ratios. And if we now take a look at this, let's be on this side of this page. Okay, so we're going to get our 3 basic ratios. And a good first step, we haven't done this so far, but a good first step here is to get some sums. Go ahead, Maureen.
I just have a question. How do you make it so that you can see the grid again?
How do you make it so that you can see the grid?
Yeah, like the grid boxes aren't online anymore.
Okay, so under your view, there's going to be something. Her grid has temporarily gone away. Under your view, and I'm not sure which one it's going to be, it might be under Windows. Okay. Your cursor still should be in the same places. Is that still? Yeah, sorry if I can't. But under the view, somewhere it's in there. I don't know. Here, view, show grid lines. How about that one? View. Okay. And then we had, oops, view and then show grid lines. Does that work? Okay, real good. I'll make that bigger. Okay, let's take some sums. So here we can just say sum, and now I'm in cell B8 and I put the word sum. And anybody remember the command for sum? Sum, equals sum, okay? Equals sum. And I'm going to sum over group number 1 first. Equals sum. And you can all yell out what value you get. 104. Okay. All right, and let's now pull that on over. Once we have that genotype, we can actually drag that over, and we can, I'll make those in red. Maybe I can make them, let's see. Oh, I'll just call them out. I've got 104, 70, and 84. Who's got that? 104, 70, and 84? Okay, real good. All right, and then let's take a grand sum as well. Let's see if we can get the grand total, and we can label it as such we wouldn't have to. We'll just call it grand and equals sum. And now what you can do is sum over those 3 sums that you just had, or you can sum over the other 12 scores, and you come to 258. So I wind up with 104, 70, 84, and 258 as my sums. And I'm going to pause there until everybody's got their hand up and confirm those numbers, because we don't want to get too far ahead even in these very rudimentary computations. Okay? And Katie, do you have those also? Do you have those sums also?
Yeah.
Okay. All right. Very good. Nina, is that okay? Thank you. All right, real good. So now what we're going to do, as we mentioned a while back, is we are going to have a structure inside of Excel that will contain the raw scores. We'll have another structure of the same number of columns, the same number of rows, that will contain the squared scores. So let's do it this way. Let's just label these as being raw scores. And what we can do is maybe copy down this much of it. I'm going to highlight over that. I'm going to make Control C. I'll come down maybe to the 11th row or so, and I'll do a paste. And now I have 2 versions of the same thing. So far, pretty boring and not at all informative just yet, but we're setting up some structure here. 104, 70, 84, 20, 258. Okay, and what we can do then is we can highlight the second set of numbers, and we can actually get rid of that, but we're still going to leave group 1, group 2, group 3. We'll leave some there. We'll just delete this, and we might put over here something like squared scores. Okay. And to delete that, you can highlight that and hit the delete key, which is just above your arrow key. Okay. And now what we're going to do is get the squared version for each of those. Okay. So I'm going to begin that. I'm in cell C12. That may or may not be where you are. And I'm going to say equals. And I'll click on the 38. And then I'll use the exponentiation sign over the 6. And I'll use a 2. And I'll square that. And I'll pause right there. I'm at 1444. I now have my first squared score. And when you get your first squared score, can you raise your hand? Okay. It looks like the whole group is there. Thank you. Okay. Then what we can do, once we have that one genotype, we can drag it down and we can drag it over. We can drag it all the way over, and we'll get some noise over on the right-hand side that we can just delete. But now we have a squared version of our raw scores just by dragging down and over. And what's nice about that is you don't have to worry about making lots of finger errors there, right? As soon as you get the first one right, you preserve all of these spatial relationships, just like we did earlier in the semester. Okay. And those numbers that I've got appear to be 10, 816, 4900, 7056, 66564. Who can corroborate those numbers? Okay, and maybe not everybody did. Let's see if.
Wait, sorry, how did you?
Okay, so let's do that again. I started here. We'll see if we can get that one. I said equals, and I clicked on the 38, and I squared it. So I raised it to the second power. So far, so good. Then in the lower right-hand corner, as we've done before, I dragged it down, and then I dragged that over. And these values I just pulled out because they're not particularly relevant. Right? We now have a squared version of everything that's up there. Did that work for you? Okay, please.
I'm not getting this 6.
Okay, and so what you want to do is you want to make sure that you're squaring the 258. Does that work for you?
Yeah.
Okay, we're squaring the 258. Okay, just a note about this, something that happens. This number, 10, 8, 16, is actually the 104 squared. And that is correct. What some people erroneously do is they square this number, this number, this number, this number. Then they take the sum of those numbers, and that's not what we want to do. We really want to square that number. Okay? So far, it looks like everybody's there. One more time by show of hands, can we all raise our hands if we have 10, 8, 16, then 4900, 7056, and 66,564. That would be the whole set. Okay, so the whole gang will be with us. I think that whole gang. How are we doing, Brittany? That work?
Yeah.
Okay, thank you. All right, now what we're going to do is finally get to our basic ratios. So here's our basic ratio set. And what we'll do is create 3 different rows, one for y, one for a, and one for t. And you can put them, if you want to label them basic ratios, that's fine. You wouldn't have to. Basic ratio. Okay. And we'll leave one for y, one for a, and one for t. And I put my labels here in B, and we'll actually compute them inside of A. Okay? So now if we look at the y basic ratio, there's some instruction there that you will not have to memorize. I will hand this to you on a test. I've been doing this for 20 years. I still use these. The person who taught me still uses these. So what we'll just do is follow that formula which says the sum of the individual squared scores. Just to remind you of where those might be, those are right here. Okay? Go to the view, and okay, I think that's all right. All right, are people fine? Maybe I can make those bold if that helps you a little bit. Okay, there they are. So we want the sum of all of those guys. So I'll say equals, I'm right next to my y. I'll say I want the equals, the sum of my bolded items. These are the individual squared values. And I wind up with 6378. Okay? And we'll see how many people can corroborate that number. Yep. I can try. I seem to have lost, when I went to help Marin, I seem to have knocked out my stuff here. Not that it's Marin's fault, it's my fault. Okay, let's try, how about this way? How about I go like this? I'll select it all, go to home, and then maybe I can make it like a 14. Is that helpful? Okay. Bigger still, or is that okay? Okay, thank you. Thank you for pointing that out, Natalie. And then what I'll do here is I'll go home, and I'll even make that yellow. So all we did was we took the sum of everything in yellow and black. Okay? And that gives us 6378. Can we get an amen on that one? Amen. All right. All right, we got an amen on 6378. Now we're going on to our second basic ratio. And again, we'll follow the recipe. I'll read it out loud to us. This is the sum of the squared column totals divided by the number of subjects per condition. Okay, so where are these column totals? These are the squared column totals, and I'll now make those red just to make it obvious, especially for our friends in the back. Okay, we want to take the sum of those guys, ding, ding, and ding, and we're going to divide that by the number of subjects per condition. So equals, we'll say sum, and we'll highlight over those three. These are the squared column totals. Okay, and we'll divide by, you tell me what number? 4, okay, and why 4? There are 4 scores per group. That's exactly right. So we're going to put that in, and we wind up with a 5693. Who can corroborate that number? Okay. All right, so now we have 2 of our 3 basic ratios. Remember, the basic ratios are going to help us get the sums of squares. Let's do one more, and I think this is actually one of the easier ones. This is the basic ratio t, and our formula, what we'll say that it's the grand total squared divided by the total number of scores, and that's the capital N. So this is going to be equals, and you can do this a couple of ways. I'm going to click on this guy. Okay, that's already our squared total. If you wanted to square it anew because you like squaring things, you could click on that guy, the 258, and square it there, but you've already done that. Okay, so we can take advantage of the fact that we've already squared this, and we're going to divide that by, you tell me, can you yell out the number? 12, okay? Now, you can put in a 12 if you want. I'm going to be a little bit more literal, and what I'm going to do, you don't have to do this, is I'm going to divide by this phrase, which is the number of persons per condition times the number of conditions. That's going to be the same thing. 4 times 3 is 12, as I'm sure you know. You can divide by 12, but I'm just going to label it as 4 times 3 because you know that we came to 12 because we have 3 groups with 4 persons per group. And I come up with a 5547. Who can corroborate that? All right, really good. Okay, so now we have our basic ratios. From our mantra, what do basic ratios do for us? They help us get the sum of squares. Okay, so what we're going to do now is the F table. We'll start to construct our own F table. Right, we're building it from scratch, and you might remember that the leftmost column in the F table is going to be our sums of squares. So right beneath these numbers, right beneath the actual basic ratios, can you join me by putting in an SS? Okay, we're going to, in just a moment, start mixing and matching those to get the SS. But before we do that, we'll build our F table. Does anybody remember what comes to the right of the SS in our F table? The DF, okay, Catherine's got it. Oops, excuse me. We're going to go over one, we'll put in the DF. And then sometimes we somehow mix and match the SS and the DF to get a, anybody remember? You can call it a variance. It would probably be better to call it the mean square or the MS. I'll put a variance up here though, because it actually is a variance. And then once we have our variances, we can get our, anybody recall? The F ratio, right? Okay, so this is the F ratio. Okay. And then after that, we might be interested in something like the p-value. You know, we can even call it the p, and then we can say this would be the sig value inside of SPSS. And we wouldn't have to do this, but just because it's Halloween and we're really enthusiastic about this, we can get our F-crit value here also. So these are going to be the labels in our F table, and we spent all day yesterday learning about F tables. Okay, one other thing that we might say over here, just to the left, we might say that we have some sources of variability. One is between, and one is within. And we remember that alphabetically, B comes before W. That was one of our little memory tricks. So now we have the layout for the F statistic, and we're going to see if we can build on what we did yesterday when I gave you a bunch of these numbers and we were understanding the internal workings of the F statistic. We'll see if we can put this together now. So we've completed this side. If you'll join me in flipping over to this side, we're going to complete the F table by taking advantage of what we've already set up here. Okay, so if I want to get the sums of squares associated with the between conditions, what should I do? Yell it out? Okay, so would you join me by putting in an equal sign? Okay, an equal sign. And then we click on the value next to A minus the value next to T. And you can hit enter. I'll leave that up there so people can see what I clicked on. I did A minus T. And you can hit enter. And you what you get when you hit the enter key? 146. Let's see if I can corroborate your number. I get a 146. Little note about that. I don't know whether that number is correct or incorrect. Actually, for other reasons, I know that is correct. But sometimes on a quiz, you'll do that, you'll hit that button, and this will turn out to be negative. If it does turn out to be negative, please stop right there and double check some earlier numbers, okay? Because you can't have a negative sums of squares. In principle, it could be 0, but it can't be negative. And usually, a couple of times a semester, I'll get some negative sums of squares here, so you should stop right there. Okay? So at least we know we have a plausible number. All right, let's do the next one down. Why don't we keep working in the sums of squares? This will be equal to, you tell me, yell it out, y minus a, okay? And I'll hit that, and I come up with a 685, and we'll see by a show of hands who can corroborate that number. 685, okay, that's working. Those were actually the harder computations, and hopefully that wasn't too bad, but we use the basic ratios to get the sums of squares. Now we have these really simple kinds of computations for the degrees of freedom. Degrees of freedom for between is a minus 1. Can somebody help us out with what a is equal to in this case? I think I heard it was 3 because there are 3 groups. Okay, so we're talking about the between group variability, and we have 3 such groups. So 3 minus 1, you can put in a 2 there if you want. I'm going to literally encode it as 3 minus 1 so I can remain true to the formula. Okay? Similarly, we'll drop down one more time, and now it's big N minus A. Can anybody help me out with those numbers? 12 minus actually 3, right, because we have 3 groups. So we have 2 and 9 degrees of freedom. And I'll pause there to make sure everybody's still with me. If you're still with me, can you raise your hand? If I've lost anybody, that's okay too. Just let me know. Okay, we're doing all right? Okay, really good. Okay, so now maybe somebody can remind us how we get a variance of any variety. We call this particular kind of variance a mean square. What do we do? Equals? Right, so equals, and then you can just dial over twice if you like. The reason why I like to dial around rather than put the numbers in, if I have to put the numbers in, I'm going to make an error. Maybe you're better than I am, but I just take advantage of the numbers that are already there divided by this, and I wind up with 73 as my mean square. And then I can, if I like, copy that same formula on down. If you prefer to key it in manually, that's okay, but that's my neighbor 2 doors to the left divided by my neighbor immediately to the left. SS over DF gives us the variance as always. We did that in the 2nd or 3rd week of class very early in the semester. Can somebody help me with the F ratio? I'll put an equal sign. What do I do here? Go ahead, Mira.
The variance between
That's exactly right? So we promised it would be about ratios, 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 okay? And just to think this through, first, I guess I'll ask you this. Can anybody corroborate that number? I'm getting 0.9591. Okay, that was the ratio of those 2 variances, between over within, from our color-coded big pie of SS the other day. We had green over red. And just so you have some idea, here's the 0 F statistic. Here's positive infinity. There's going to be some critical value we could find out. We chimed in right about here because our F ratio turned out to be actually slightly less than 1. Who's following that? Does that work for us? We just computed an F ratio that turned out to be 0.959. So it's right over here. That's where we're landing on this big map. Sometimes it's easy to see it visually. Okay? Anybody have an idea before we go much further? Are we going to wind up retaining or rejecting this one? Okay, let's do it this way. Let's vote with one finger if we think we're going to reject the null hypothesis, two fingers if we think we're going to retain the null hypothesis, and three fingers if you don't know what I'm talking about, and that's perfectly reasonable. Okay? One finger is reject the null hypothesis, two is retain, three is I'm not sure what this guy's talking about. Okay? I see at least one 3. I see a couple of 3s. Thank you. Okay, thanks. Who might have... Meg, if I can call on you. You put up a 2 early, and you're correct to put up a 2, which means we're going to be retaining the null hypothesis. Can you tell us why?
Because it's not okay with
Right. This is the rejection region. We need to be way out here. If we land out here, we've got a really big value of f, which will mean we'll have a really, really low value of the observed alpha level, and we reject the null hypothesis. Okay? But we didn't even make it this far. We need to get out here to say that we've got sufficient evidence to reject the null hypothesis. Who's okay with that line of reasoning? Would anybody like greater clarity on that? It's okay if you do. Okay? All right, great. Okay, so we will actually formally compute the remainder of it, but we have some idea about which way this thing is going to go. We know it's going to be a retain. Okay? Anybody want to remind us what command inside of Excel will get us the sig value or the observed value of the alpha level? Fdist. Okay, Jenna's got it. It's equals Fdist. Fdist, and that's equals Fdist in a left paren, can be a little bit confusing here. They prompt you with an X. What they really want you to put in is the observed value of f, which is right next door. So the value of f that you and I observed was 0.959, and then comma, and I mentioned this in the video, we need to get the degrees of freedom in the correct sequence. The degrees of freedom in the correct sequence is always numerator and then denominator. So if you'll click on the 2 with me, we have 2 degrees of freedom in our numerator, comma, 9 in our denominator, and you can put a right parenthesis there. I'll leave that there. I'll let you hit enter, and you can yell out what you get. 0.4192, 0.4192. Okay, show of hands, how many people can corroborate that? It sounded pretty robust here, okay? And as we know, that number is actually nowhere near 0.05. And our rule is always, if it's less than 0.05, we reject. Otherwise, we retain. So we wind up over here, and we're nowhere near the 0.05 level. Okay, so we're going to wind up retaining. Just for kicks, how big would the f value would have to be, or how large would we need to have on this axis in order to reject the null hypothesis? We can get that using the f crit. That'll give us the critical value, and this will be f inv. Okay, what's our favorite probability? 0.05, always in this class. Degrees of freedom, same as before. We had 2 in the numerator. That's for between, because we had 3 groups, and then we had 9 in the denominator. Okay, and we come to a 4.25 in this case. Okay, so this value would have to have been 4.25. Had we gotten an f that was 4.25 or larger, we would have made our burden. We would have had enough evidence to reject the null hypothesis, but we didn't get up to 4.2. In fact, we didn't even make it to 1. We almost made it to 1, but not further than that. Okay? So what we can say then, after all of that, is we're going to wind up retaining HO. In this particular data set, we don't have significant differences across these means. Let me take a pause there and see who has questions or comments about that much. Okay, I think the whole group is there. Great. Okay, why don't we do one more thing, and then we'll see if we can carry these numbers over to SPSS, and we'll see if we can corroborate the numbers in SPSS. Just as you might recall, the American Psychological Association does like us to put this into a certain kind of a format. So let's get some practice doing that. We're going to be reporting to our audience what we did statistically, and we will report to them that we had an F statistic, and it had, you tell me, how many degrees of freedom? Can we yell it out? How many degrees of freedom in our F? It's actually 2 and 9 is how we report that. Okay? That particular statistic does have 2 separate indicators for degrees of freedom. The observed value was 0.9591. I'm not a real stickler for how you do the rounding there. I frequently go to 3 digits. Okay? And then we can also say that the p-value associated with that was equal to, and we can put it in exactly, we have 0.4192. Frequently, when we have a non-significant p-value, we put in n.s, and that stands for non-significant. And we could say retain HO. Strictly speaking, I think we've departed a little bit from APA style, but this is the information I'd like you to get down. This much certainly is APA style. The statistic, the degrees of freedom, the observed value, and the p-value. This is sort of up for grabs. Please go ahead.
So this is in contrast to what we were doing before, where you wanted us to put p less than 0.05 or p greater.
That's right. That's right. 'Cause yeah, that's actually preferred if we can do that. Yep. Yeah. In days gone by, actually even before I got into the game 20 years ago, we didn't have access to such computing power, and there would be tables that would tell you that you were less than 0.05 or not. But now that we have that information right there, we typically prefer to report that. Okay. Who follows all that? Is that working for us? Okay. All right. Any questions or comments? Well, congratulations. You made it through your first basic ratio computation. I hope that wasn't too spooky. Okay? All right, now what I'd like to do is same thing. We'll do the same problem one more time, but we won't do it manually. We'll see if we can get SPSS to do all of that for us. So if you would please open up SPSS, and we're going to open to a blank data sheet. You can click on your SPSS icon, which is down here. It's the blue one. And frequently when we've been working with this in the last several weeks, we've had you open up different kinds of files. And we'll be doing that again. We'll have you open up existing files. But it's also been, I think, maybe 2 weeks or more since we've actually input data in SPSS. Many of you will go on to do your own empirical work here at Denison, either in psychology or somewhere else. And so it's helpful if we can have you learn how to begin creating these data structures. So why don't we get to variable view? And we'll just have a little conversation first about what variables we think we might need to create inside of variable view to run the ANOVA that we just did. Anybody have an idea about some of the variables we might use? Okay, thanks, Kip. Okay, right, so our independent variable really is one variable, right? And we can even call it group or something like that, and we'll have group 1, group 2, and group 3. Okay, that's one of the items that we're going to have. Something else that we might need? Any other ideas? Frequently, it's a good idea to start out with a participant variable, just so we can label who's in which group and all of that stuff. So would you join me? First, let me make sure everybody's got this open. Who's on variable view in SPSS? Are we all there? Okay. So if you're on variable view, can we create our first variable by calling it participant? And we'll put something in for participant 1, participant 2, participant 3. Okay. It's kind of a boring variable, but it's a little bit of a placeholder. And you can hit enter if you want. And all of these cells populate. But what I'd like to do is I'd like to be able to refer to each of my participants somewhat confidentially. I'd like to be able to, instead of calling Maddie, Maddie, and Nina, Nina, we might call them P1 and P2. So if I am going to be calling them P1 and P2, I'm going to be entering some letters. Does anybody remember what we have to do in SPSS if we're entering information for a variable in letter form? Go ahead, Kip. Yeah, okay, so under variable type, we've just typed in participant. Right next door is type. And if we click on that, you'll get a little bubble menu. If you click on that, you'll bring this submenu up and you can click on string. Okay? I'll leave that there. You can hit enter, or rather OK. Okay? And this will now allow us to put in names if we wanted to. Typically in psychology, we try to avoid using a person's name because that's a violation of their confidentiality. And frequently, the data that we have on them is not particularly sensitive. It might be their score on a reaction time test. But just to preserve their confidentiality, we might call them P1 and P2. Who's got that? That work for us? Okay. We might have another variable that Kip alluded to, and that's simply the group variable. Okay. And I'll hit enter. And this can be numeric. Wouldn't have to be numeric. But what I would like to do is create some value labels just to remind us how to do that. In this particular case, we have pretty boring value labels. We have 3 groups, and we can call the first one group 1, the second one group 2, and the last one group 3. But it could have been something like chocolate, vanilla, and strawberry if we were doing an ice cream test or something along these lines. If you click on values with me, we'll put in the first value as 1. That's how we will refer to group 1. And I'll add that. The value label of 2 will refer to group 2. And the value label of 3 could refer to group 3. But these could have been different flavors of ice cream. These could have been different levels of Prozac that I've been mentioning before, 0, 1, 2, and 3 milligrams Prozac. But we'll leave it at just group 1, group 2, and group 3. And I'll click on OK. And before I go further, I'll see who's OK with that. Okay. And then one last thing, if we could, we'd like to have a participant. We'd like to designate which group Marin is in and which group Hannah is in and so forth. And we'll need a placeholder for their score. Okay? So we now have a score variable, and that's a numeric variable. We can click over to data, okay, and we've got all of this. Okay? Participant, group, and score. Okay, why don't we do it this way? We had a total of 12. You stay right there. I'll just show you what the data looked like again. I'll flip back over. And our data looked like this. You might remember that we had 3 groups. And maybe I can make that a slightly different color. I can put that into a light green background. 3 groups. So why don't we call, make that green also. Okay. Why don't we think of this one as P1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you'll join me over in SPSS, we'll put in those P's. So I'm now over in data view, and hopefully you now have 3 columns, okay, in data view. And we'll just put in P1, enter P2, P3, P4, P5. This portion of the process can be a little bit tedious. It's not particularly intellectual, just putting in all those numbers. Somebody once said that science is 99% perspiration and 1% inspiration. So a lot of perspiration is putting this stuff in. Okay. And then groups. Why don't we think of it this way? Why don't we make the first 4 ones? If you click on a 1, you'll notice that it populates immediately with the group 1 as soon as you hit enter. And then we'll do the next 4 with a 2. And we'll do the remaining ones with a 3. Okay, so I'm putting in a 1. So if I put in a 1, and I'll toggle past that in just a moment. If I put in a 1, you might either get a 1 or you might get a group 1. You get a 1, okay. Now if we go over here to view, and we click on value labels, I can see that I get all 1s, 2s, and 3s. If I go to view and I toggle back over to value labels, I get these. Okay. So why don't we do that, just as a reminder. Can we all toggle back and forth on value labels? We go up to view, and we'll just toggle back and forth. We haven't done that in a little while. Right, so it's good that we revisit that. Okay. All right, and now we have the challenge of trying to get in these 12 values here. A couple of ways of doing it. Maybe I can bring this down a little bit, open up Excel, and why don't I highlight over the first group. I'll pick up those numbers. 38, 30, 17, and 19 is what I've got highlighted. And what I can do is a Control-C, and I get that ring around the rosy. Okay, that's telling me that I've got those numbers in my memory buffer. I can minimize that and do a Control-V over here in SPSS, and I now have my first 4 scores. Who's all right with that? Okay, did I lose anybody on that? And if you don't want to do it that way, that's cool. I can just call them out to you. 38, 30, 17, 19. Okay? And you can keep your eye on me too in case I have a misnumber. All right, now we're going to go over to here, and I'll highlight the next 3. I'm in group 2, and I'll do a Control-C. And I'm going to pick up 20, 25, 10, and 15. I flip back over, and I paste these with a Control-V as in victory into the group 2 portions. Participants 5 through 8 gives me 20, 25, 10, and 15. Who can corroborate those numbers? Okay, really good. One more time, and we're done. In pulling the data over, I'll grab group 3 with the Control-C. Come over to here, and I'll paste that in. And I have 30, 27, 9, and 18 from there and there. All right, I can make that nice and big. So from the top, 38, 30, 17, 19, 20, 25, 10, 15, 30, 27, 9, 18. Who can corroborate those numbers? Looks like the whole gang is there. Is that working for you? Yeah, okay, very good. All right, so now what we're going to do is have SPSS run the analysis for us. And anybody want to remind us how we get this analysis going? Or anybody want to guess? You might think it would be analyze, right? Okay, so that would be a good start. And we're going to do here compare means. By the way, just in case you're wondering where I'm getting these clicks from, on the very last slide of our last PowerPoint, the one that we finished yesterday, there's a list of them here. So you don't have to jot this down. You can if you want to, but you don't have to. I would like you to know where to click once we get to a computer quiz, but you don't have to jot that down now. It's available to you in PowerPoint. So here we're going analyze. We're going to be comparing means, and you tell me which one to pick. One-way ANOVA, and I'll click all the way down to there, but I won't hit my left key until you do. I'll let you see my path, analyze, compare means, one-way ANOVA. One way because we have one variable, happens to have 3 levels. Does that work for us? Okay, I'll click on that. All right, and then this is what we get. If you had that PowerPoint up, you would see this, and it would tell you that the dependent list contains your score variable, your dependent variable, and your factor is your group. Sometimes we use the word factor synonymously with an independent variable. Okay? So score up top, group on the bottom. Okay? Now we'll do a couple of other things. I'm just following right off the list here. And what we can do is go into options. And we can get some descriptive statistics. We can have the computer tell us what the means and standard deviations might be, that kind of a thing. There's one other thing that we might want to click on. Can you please click on the third one down, which says homogeneity of variance test? While you're clicking there, I wonder if the group can call out what is going to be the name of that test. Does anybody recall? The homogeneity of variance, it's called Levene's test. Okay, so we want to check out Levene's, which is something we actually didn't do inside of Excel. We were just computing the basic ratios. So I'll click on continue. Okay. And then let's also get some post-hoc tests. Okay. And a ton of them are here. I mentioned 3 of them the other day. Let's go with the Tukey, not the Tukey's B, but the Tukey. And why don't we go with the Chaffee? That's what we had shown in a prior example. So we've got Tukey and Chaffee, so we can do some post-hoc tests, and we'll say continue. Okay. All right, and then we'll click on OK. And the computer will go into a pause just for a moment, and we get out some descriptive statistics. Okay. All right, so hopefully this all looks good. We can see that we really did get 4 people in each of the groups. Those are the means. They're not looking wildly different from each other, especially if we consider the standard deviation and the standard error. They're looking like they're not very different from each other. Okay, here we have the test of homogeneity of variance, the Levene statistic that we talked about before. I'll let you look at that, and then we'll have somebody raise their hand and see if they can explain what we need to do with this box, what decision we need to make here. Looking at the test of homogeneity of variances. And if you think you know what to do here, maybe you can raise your hand. If you're not sure, was that a hand or? Okay, thanks, Maddie. Okay. We're going to retain the equal variance assumption here in this case. Okay. We're looking at the equal variance assumption. Homogeneity means equal, at least roughly. And so we have at least roughly equal variances across our groups, and we're going to retain because that value is greater than 0.05. First, show of hands, who's following that logic? Who remembers doing that before? Okay? This is a 2-step process where before we get to evaluating the null hypothesis, we actually have to look to make sure that our assumption is okay. And in this particular case, our assumption is okay. Okay, we have that. Jenna and Kip had their hands up. Is that what you were going to suggest? Okay. All right, so it looks like we're there. So we now have the green light. We can go ahead and take a look at this. And hopefully these numbers look relatively familiar to you. What I'll do is I'll leave these up here. If you want to toggle back over to Excel, if you have it still open, and at least within rounding error, I think you'll see that you can corroborate these numbers. You might remember computing 146 and 685. You might remember computing 2 and 9. These might look familiar. There's our F value. It almost made it to 1. And we might have a slightly different number just based on rounding. And then our sig value should have been what we came up with in our F dist. Who can corroborate those numbers? Okay. So the good news is SPSS got it right. Okay. SPSS got it right. And you can always check up on SPSS by doing what you just did inside of Excel. Okay. All right. Questions on any of that before we go further? Okay, why don't we drop down and take a look at the post-hoc tests? Okay, so now we've got some post-hoc information here. Okay, I'll let you peruse that, and then maybe we can have somebody at least begin to walk us through what the post-hoc tests are telling us. Those are busy boxes, so you might need a moment or two to make some sense out of it. Okay, would you like to get us started? Katie?
Well, since we know that there's a correlation between at least one of the means, this tells us which means are.
Right, actually what we found out, we don't really need to be looking at this. I'm asking you to look at it, but we actually know that there are no differences, okay? But you're correct that this would help us pinpoint where the difference might be, right? So if we actually had a significant effect, then we'd want to find out where that significance might be. In this particular case, we wouldn't need to look, but we're looking anyway, and Katie's correct that it would help us pinpoint that difference, okay? Okay, anybody else want to say anything more about what's going on here? Maybe somebody can help us interpret. Well, why don't we start with the first, the very top line, group 1 versus group 2. Anybody want to help us out with what's going on there? Okay, thanks, Jenna.
Well, it's a positive number, so that suggests that group 1 score is higher than group 2.
Okay, perfect. Group 1 score is higher than group 2. That gave us a positive difference. And then what do we say about the sig value there? Can you help us?
Well, it's greater than 0.05.
Right, okay, so we have a positive difference, but it's not a significant difference, right? We're pretty far away from this boundary. We're not getting an exact F value here, but we're pretty far away from that boundary, so that was a non-significant difference. Can somebody else help us out with interpreting the 95% confidence interval in this case? Okay, we've done that a couple of times before. The 95% confidence interval for that same top line. Okay, yeah, thanks, Natalie.
I think it's like the means fall between negative, or 95% confident that the means fall between -8 and -12.
Between -8 and, what was the other one?
-12?
Almost. Not between -8 and -12, but yeah, so the upper bound would be positive 25, and the lower bound is -8. Okay, so we're pretty sure that the mean falls somewhere in between there. Why is that an important set of boundaries? Can anybody help us out with that? Lower bound is -8. The upper bound is 25. Why is that an important set of boundaries? Any notion about that? Okay. See if we can draw this one more time. Okay. What we can do is plot these difference scores. Okay. And this is 0. And this is really what the null hypothesis is calling for. They're calling for a difference between any particular combination of means that's going to be somewhere near 0. It might not be exactly 0, but it will be somewhere near 0. If we stay with Natalie's logic that we have the 95% confidence interval ranging between -8 and positive 25, I'll just freehand that over here. -8 might be here-ish. Positive 25 might be here-ish. Okay? So we get this kind of a 95% confidence interval. And the actual mean, I think Jenna told us, was about positive 8. So maybe something like here. That's roughly where we are. And we estimate that the actual difference is about that amount, which is fairly close to 0. We're 95% confident that the actual difference is going to be somewhere in here. Okay? And that is to say that the 95% confidence interval actually does contain the 0, which is what's predicted by the null hypothesis. So the null hypothesis is making a prediction that is falling within the 95% confidence range. So we're going to wind up retaining the null hypothesis. Who's following that? Okay, does that work for us? Really good, really good. Okay. I think that's as far as we need to go. You really wouldn't need to know about homogeneous subsets. Just to give you a heads up about that, what this can do is it can group the various conditions, in this case groups 1, 2, and 3, that are similar to each other on mean. Okay? On average, these 3 are similar to each other, and had group 1 been different, for example, it would have been listed over here in another box all by itself. Okay? And had groups 2 and 3 been very similar to each other, then they would be together inside of their own box. But right now, all of them are in the same column. They're all relatively similar to each other. Okay, questions or comments on any of that? Let's begin to remind you of what you've done, because you'll have to do one of these in the not too distant future for a computer test. We started out inside of Excel, and we used those basic ratios to get some sums of squares, and then we manually computed the F table. After we got the F table, we were able to come to an F value, and we made a determination about whether we retain or reject the null hypothesis, and we wound up retaining in this case. Then we went over to SPSS, and we thought about how we might code all of that information. We created a couple of different variables, a placeholder for the participants. We had some way of designating who is in which group, and then we needed a place for each of their individual scores. We made an analysis that required comparing means, and we did a couple of post-hoc tests. It turned out we didn't need the post-hoc tests here, but we could not have known that earlier on, and it looks like we had no differences across all of those 3 different groups. Okay, questions or comments? All right, why don't we draw the line there? Look forward to seeing you on Friday, when you will be responding to these questions. This will help you try to get your brains around which kinds of tests we use statistically for which kinds of designs, and how they link to different variable types. when we come back on Friday too, maybe we'll have some people give some examples in class, and we'll go through another basic ratio exercise, because we do need some practice on this. All right, I hope you enjoy Halloween, and I'll see you Friday.